Okay, guys, so this video is going to be talking about myths about randomness. So we kind of have a good idea of what probability is, but then um, no, our intuition is going to naturally make us have some misconceptions about probability and more specifically about randomness. So um, the the idea of probability is pretty straightforward. It answers the questions: what would happen if we did this many times? In fact, both behavior of random phenomena and the idea of probability are a bit subtle. The idea of probability is that randomness is predictable in the long run. Unfortunately, our intuition about randomness tries to tell us that random phenomena should also be predictable in the short run. When they aren't, we're going to start to look for an explanation other than chance variation as to why this would occur. So we're going to start to talk a lot about different runs of outcomes in this topic, and a run is going to be a repetition of the same result. So rolling a die and continuously rolling a 6. So here's an example that deals a little bit with that, and it's about tossing a coin. So we're going to toss a coin 6 times and record heads or tails on each toss. So which of the following outcomes do you think is more probable? So think about it, take a guess. So almost everyone is going to say heads, tails, heads, tails, tails, heads is more probable because tails, 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 heads, heads, heads does not look random. In fact, both are equally likely. That heads and tails are equally probable says only about half of a very long sequence of tosses will be heads. It doesn't say that heads and tails must come close to alternating in the short run. The coin has no memory. It doesn't know what past outcomes were, and it can't try to create a balanced sequence. So it wouldn't matter. So the outcome tails, 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 heads, heads, heads in tossing 6 coins looks unusual because of the run of 3 straight tails and 3 straight heads. Runs may seem that they're not random to our intuition, but they are very common. Here is a more striking example than coin tosses. So is there such a thing as a hot hand in basketball? Belief that runs must result from something other than just chance influences behavior. If a basketball player makes several consecutive shots, both the fans and her teammates believe that she has a hot hand and is more likely to make the next shot. Several studies have shown that runs of baskets made or missed are no more frequent in basketball than would be expected if the result of each shot is unrelated to the outcomes of the player's previous shots. If a player makes half her shots in the long run, her made shots and misses behave just like coin tosses. And that means that runs of makes and misses are more common than our intuition expects. So free throws may be a different story. A recent study suggests that players who shoot 2 free throws are slightly more likely to make the second shot if they make the first shot. So in a casino, when the shooter in the dice game called craps rolls several winners in a row, some gamblers think that she has a hot hand and bet that she will keep on winning. Others say that the law of averages means that she now has to lose so that the wins and losses will start to balance out. Believers in the law of averages think that if you toss a coin 6 times and get tails, 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 the next toss must more than likely be a heads. Um, it is true that in the long run, heads will appear half the time, but again, that does not necessarily mean that you would get a heads just because you had a run of 6 straight tails. So it is a myth to think that future outcomes must make up for some imbalance, um, like 6 straight tails in a coin toss. Coins and dice, again, they have no memories. So a coin doesn't know that the first 6 outcomes were all tails, and it can't try to get a heads on the next toss to even things out, because it doesn't even know what it got the time before. So in the long run, things will even out, and that's the law of large numbers. Okay, so here's a kind of funny example about the law of averages. So the law of averages is, of course, a myth, and it's a myth of randomness that they would have to start to balance. It's not true. Um, so here's a good example of it. So, belief in this phony law of averages can lead to serious consequences. A few years ago, an advice columnist had planned to limit their family to 4 children, but they wanted to have at least one boy. When the first of 4 children, when the first 4 children were all girls, they tried again and again and again. After 7 straight girls, even her doctor assured her that the law of averages was in our favor 100 to 1. Unfortunately for this couple, having children is like tossing a coin. 8 girls in a row is highly unlikely, but once 7 girls have been born, it is not all unlikely that the next child will be a girl, and it was. Okay, guys, so here's a quick check your understanding. So you should probably pause your screen, explain what you see about the chance behavior in the short run and long run of this. It's a virtual basketball player shooting free throws. So um, examine the graph and write what you see about the short run versus the long run. And then the next slide, it has a little bit of an answer. You might have some flexibility in your answer than from mine. And that's it. That's the end of this video.